Okay, in this video, we're going to go over a lab that covers static and summary routes. The lab is from Flackbox, which is flackbox.com. Neil Anderson's the teacher of this course. You can find it at flackbox.com. And just look for Neil Anderson. The course that I'm taking from him is the CCNA Gold Bootcamp. It's like $50. It's totally worth it. And I thought it would be fun to walk through this lab and show you what some of the Flackbox labs are like. And so let's get started. The nice thing about Flackbox is it provides you with instructions, and it also provides you an answer key with the instructions. I usually, I'll pull it up, I'll have it there, but it's best to try to walk through it and get everything done without it. And then if you get stuck, you refer to the answer key, so it's good to have. So we'll just get started. It says say no when asked when you'd like to enter initial configuration. That's fine. Configure host names on the routers according to the lab topology diagram. I'm going to turn on my cursor here, highlighter, so you can see it. So configure host names on the routers according to lab topology diagram. So we'll start with R1, and let's go there. And let's get into global configuration mode. We're going to name it R1. And we'll go to the next one, which is going to be R2. And open it up. And go into global configuration mode again. And it's going to be hostname R2. Okay. And then let's move to R3. Do the same. And it's going to be hostname, hostname R3. There we go. And fourth router, enable, T, and give it the hostname R4. And that leaves us just one, which is router 5. And we will name it and it's going to be hostname, and hostname is the command, and then you just tell it the name you want to use. So R5. Okay, that's done. We'll close this out. And a quick note on the diagram, the topology here. I've labeled each of the networks with the boxes to make it a little easier to follow along. And then each of the interfaces that belong to the network. So this is the 10.1.1.0/24 network. The interface, this interface would be 10.1.1.1. This would be .2. So each network's been labeled. The interfaces have been labeled to make it a little easier to follow along. So now we want to configure IP addresses on R1 according to the lab topology diagram. So R1 is in the 10, partially, it's actually connected to 3 networks, 10.0.0.0, 10.0.1.0, and 10.0.2.0. So let's start by giving it the IP addresses. So we're going to go to interface. Let's do this instead. Do show IP interface brief, so we can see what interfaces we have to work with. We'll open this up a little bit. So we have, scoot this over a little. We have fast Ethernet. Just back a bit. There we go. 00, 01, 10, and 11. We'll start with 00. So that's going to go to interface. Let me move this out of the way so you can see interface, and I'm just tabbing to fill it in. So that's going to be fast Ethernet 00, and it's going to give it, we're going to give it the IP address of 10.0.0. And it's a .1, and a subnet mask of 255.255, no, .0. Okay, because it's a /24. Oh, I made a mistake. Up arrow, down arrow, and let's put in that D that I missed there. There we go. And then we're going to go to fast, we're going to go to the next one, which is going to be fast Ethernet 01 on our list, and that's going to be right here. And it is part of the 10.0.1.0 network. So let's do that. Exit out of there. interface fast Ethernet 01, and let's give it the IP address of 10.0.1.1. 10.0.1.1. Yep, that's right, with a subnet mask of 255.255.255.0, because it's a /24 network, as you can see right there. Enter. And let's go on to the next one, which is going to be fast Ethernet 10. So we'll exit out of here. We'll go to the interface fast Ethernet 10. And we're going to give it the IP address of 10.0.2.1. And so IP address is 10.0.2.1. And I did incomplete command. I forgot the subnet mask of 255. Okay, there we go. That's done. And that should leave us with fast Ethernet 1.1. So let's get that one done. Exit. And we're going to go to the interface fast Ethernet 1.1. And it's going to have the IP address of, it's in this network, 10.0.3.0 and 0.3, and it's going to be the .1. So that should be, oh, I did it again. I forgot the 255.255.255.0, because you got to have a subnet, and that's there. So let's do show IP interface brief to see if we have those all set up. So we have fast Ethernet 00, which is 10.0.0.1. We have fast Ethernet 01, which is 10.0.1.1. We have 10, fast Ethernet 10, so 10.0.2.1, and fast Ethernet 11, which is 10.0.3.1. So we've completed that part, configure IP addresses on R1. That's done. So now we want to verify that routes have been automatically added for the connected and local networks. Note that local routes only appear from iOS 15. So let's do that. So open up the prompt there, the command line. And we're going to do a do show IP route command. And this is going to show us what is currently available. So right now nothing's available because I didn't bring the interfaces up. So what we're going to do is we're going to go back in here, and we're going to do a exit command, and we're going to do a interfaces. We're going to do a range this time, the interface range command, because I'm going to bring up all 4 of the interfaces up at once. And so you just type in the interface range command, followed by fast Ethernet 00, comma, fast Ethernet 01, comma, fast Ethernet 10, comma, and fast Ethernet 11. So we have 00, we have 01, we have 10, and 11. And then you hit enter. And now what we got to do is enter the no shut command, because we're in the interface range configuration mode. So you can issue one command and hit a bunch of interfaces. This is a really cool, super useful command, especially if you're on a switch and you have 10 interfaces that you need to shut down at one time. You just enter your range and you hit the command one time for it. So there we go. So now that we've done that, you can see that some of the interfaces have come up with the green as opposed to the red. The reason that these are green and these are red is a switch. The interface is live automatically. It's up by default. Other routers, their interfaces are not up by default. That's a security thing. So right now this connection isn't live, so there's still red there. But we've done that. So let's do a do show IP interface brief command. Okay, and we can see that we have the 4 interfaces, the IP addresses have been assigned, and they've been administratively brought up. So that's done. So we have, oh, and we need to verify the routes. So let's do that now, since I hadn't done that. So do show this out of the way, IP route. And now we're going to see that for the interfaces that we brought up, that we issued the no shutdown command for, that are connected to other devices that have active interfaces, it'll automatically add those routes to the routing table. So this router, router 1, automatically added the 10.0.1.0, which is here, and the 10.0.2.0 network, which is here. Now these numbers, 10.0.1.1, that's showing you the local route, and it's always it'll have the interface IP and then a /32 every time. It's always going to show /32 regardless of what subnet you configured for that interface. This bit of information, the local routes, you'll only see that in Cisco iOS 15 and above. Previous to 15, you're not going to see that. So this is a nice little extra bit of information that's provided there. So we've done that, we've configured, we've verified routes, and it says, do you see routes for all networks that R1 is directly connected to you? And why or why not? Well, I explained that, yes, we do for the ones that the interface is up and connected to another active device, but for those that where the actual connection is still down over here, this interface is down, we don't see those active routes being added yet. So it says, should you be able to ping from PC1 to PC2? Verify this. Well, I think so, because we know that this router knows these routes. It knows about this network. It knows about this network. So let's give it a try. So we'll go and we'll open the command prompt for PC1, and we'll ping PC2, which is 10.0.2.10. And let's see what happens. We'll give it a second here. It'll probably do an ARP request first. There it was. That's why it timed out. But then we have a good ping. So we're getting information. We're getting a message there and back, so we know that's good. So now we want to verify the traffic path from PC1 to PC2. So to do that, you use the traceroute command. And in Windows, it's just trace RT. And then you tell her where you're going, 10.0.2.10, and we'll see the route. So it went first to 10.0.1.1, which is this interface right here, 10.0.1.1, and then onto the PC2, which is 10.0.2.10. So that worked. And we verified the traceroute. Should be able to ping from PC1 to PC3? Well, no, the answer is no. We could verify it, but there's no need. It'll just, the ping will time out, because we know this isn't, these interfaces aren't even up yet, so there's no way it'll happen. So let's go to static routes. Configure IP addresses on R2, 3, and 4 according to the lab topology diagram. Do not configure the Internet Fast Ethernet 1.1, which is here, on R4. Do not configure R5. So we're going to leave out this interface and this router completely. And let's go ahead and configure the IP addresses here. So we'll go to R2. We're going to enable global configuration mode. We want to go to interface, Fast Ethernet. We're going to go to 00. And we're going to assign an IP address of 10.0.0.2. 255.255.255.0 because it's a /24 network, as you can see there. And then we're going to exit out. We're going to go back to interface, Fast Ethernet, and we did 00, so now we need to do 01, 1, and we're going to give it the IP address of 10.1.0.2 because it's part of this network, this interface, and a subnet of 255.255.255.0. Okay, so we've done that on router 2. Let's go to router 3. Do the same. Enable comp P for global configuration mode or configure terminal. So on router 3, we need to get into interface fast Ethernet 01. We're going to give it an IP address of 10.1.0.1 with subnet of 255.255.255.0 because it's a /24 insider notation. And now let's exit out of there. Oh, I forgot to do the no shutdown command on R2. We'll have to go back. And then we will do the, let me get back into interface fast Ethernet 0/1, and we'll do the no shutdown command. And now we're going to go to interface fast Ethernet 0/0 on R3, and we're going to issue the no shut command. Okay, and then it didn't come active, it's still red because I forgot on R2 to issue the no shut command. So we can just do it interface by interface. So no shut, and this is fast Ethernet 0/1. No shut, not shut. So that one's up, and we're going to go to interface fast Ethernet 0/0, and again issue the no shutdown command. Okay, now you can see they're green, so they're active. Okay, so we've done those. Let's get to let's do a quick do show IP interface brief. Okay, for router 2, and you can see the two interfaces have been assigned, and the status is up and up because they are connected to active interfaces here and here and here and here. Okay, and then let's do the same thing over at router 3. Do show IP interface brief, and let's open this up a little bit. And I still need to do configure fast Ethernet 0/0 because fast Ethernet 101, which is here, is up and up. So let's go to exit interface fast Ethernet 0/0, and we're going to give it an IP address of 10.1.1.2 with a subnet of 255.255.255.0. Okay, and we'll arrow up to get to the previous commands. Do show IP interface brief. I'm just using the arrow command to see that, and now we can see that 0001 are both have IP addresses assigned, and they are both up. Fast Ethernet 0/0 is up down. We administratively set it up with the no shutdown command, but this interface still hasn't been configured, so we got to go over here to router 4, and we're going to configure, and we're going to add IP. We're going to go to interface fast Ethernet 0/0. We're going to add the IP address of 10.1.1.1 255.255.255.0 Subnet Mask. Issue the no shut command. Okay, and then let's exit out and go to interface fast Ethernet, and that's 0/1 over here. All right, and we're going to give it the IP address of, what's that one going to be? 0/1 is in the 10.1.2.0 network. 10.1.2.1 will be its IP address with subnet of 255.255.255.0, and there it is. And no shut, and you can see now that that one's active. Now it said do not configure the interface for fast Ethernet 1/1 and don't configure 5, but we do still need to configure this fast Ethernet 1/0. So let's go into here, exit interface fast Ethernet 1/0, and let's give it an IP address of, it's the 10.1.3.0 network, 10.1.3. And it's going to be 1 and 255.255.255.0 for a subnet. And let's do a do show IP interface brief. Oh, no shutdown. I got to do the no shut command. There we go. And then we're going to do show IP interface brief. Okay, and that network we see has the 3 of the 4 interfaces with IP addresses, and they've been brought administratively up. So we configured IP addresses on 2, 3, and 4, and now we're off to verify PC3, which is here, can ping its default gateway, which is here, of 10.1.2.1. So let's ping that. And we'll open the command prompt, and we'll ping, and we need to ping 10.1.2.1. Let's see if it sees it. And yes, we've got a good response, so that's an active connection. Verify, okay, PC3 can ping. So configure static routes on R1, 2, 3, and 4 to allow connectivity between all their subnets. Use /24 prefixes for each network. So earlier we spoke about R1 and its directly connected networks, and we'll look at the routing table there right quick. And we'll do show IP route. Okay, so now router 1, we can see that the connected, directly connected networks, it sees this one, 10.0.0.0. It sees this one, 10.0.0. This one, 10.0.1.0 right here. And it also sees 10.0.2.1, which is, or 2.0, which is here. And it also has included the local. So that's the /32/32/32 for the interfaces. Okay, so now what we have to do, so although R1 knows about its directly connected networks, it knows nothing about these networks over here. It doesn't know about this one, this one, this one, etc. So what we'll do is in R1, we're going to, in global configuration mode, we're going to assign static routes. So the first static route we want to assign is for the 10.1.0.0 network. So we're going to enter the command IP route. We're going to enter the network 10.1.0.0 and the subnet mask, which is 255.255.255.0. And you have to add the next hop to tell this router what direction to take. So the next hop here is going to be on router 2, which is 10.0.0.2. And 10.0.0.2 is the next hop. So again, you have the network address, the subnet mask for the network, and the next hop that the routing table needs to show. So let's pull up our do show IP route, and now we see that router 1 is aware of the 10.1.0.0 network via interface 10.0.0.2. So now let's configure this one. So we'll do a couple up arrows. We're going to do the 10.1.1.0. So let's scroll over, and we can put that in there, 10.1.1.0, same subnet, and it's also going to be the same next hop because it's here, this interface. Hit enter. Let's configure, we got 10.1.1.0, now we need to configure 10.1.2.0. So IP route 10.1.2.0, and you can use, everything else will be the same. I use Control E to jump to the end. You can use Control E or to get to the end, or Control A. There's Control A, here's Control E to jump around. So we've got 10.1.2.0, and let's add, I don't think we're supposed to configure anything for the 203 network, but we do want to add this one. So, although it didn't say not to, so let's go ahead and do that anyway. IP route 20 is going to be the network of 203.0.113.0 subnet 0, and the next hop is the same, 10.0.0.2. So that should add the 203.0.113.0. Enter that, and let's pull up our routes. Do show IP route. So we've got 10.1.0.0 added. We've got 10.1.1.0 added. 10.1.2.0 added. 203.13.0, and we need to add. Let's do 10.1.1.2.1. 10.0.3.0 network, which is here, same subnet of 255.255, and we'll go to the end, we'll hit enter, and let's do the do show IP route again, more. So we've got 100, 110, 120, 130, and 2030, 1130 have all been added for router 1. So that's everything it looks like, because we've got all these. Oh, and it's going to pick up, it'll pick up the 10.0.3.0 network as soon as we bring this interface up. So let's move to router 2. This time let's work to the networks to the right. It's already aware of this network because it's directly connected. So let's make static routes for these two networks. So we're going to exit out. We're going to do IP route, and we're going to give it the 10.0.1.0 network, and 255 is its subnet. And for router 2, the next hop is going to be over at router 1, which is 10.0.0.1. 10.0.0.1, that's its next hop to get to that network. Okay, and then let's add the 10.0.2.0 network, and we'll go to the end, same next hop. Okay, and then we'll do a do show IP route, see the routing table, and let's see what it's got. Okay, so router 2 is directly connected to 10.0.0.0. It's also directly connected to 10.1.0.0. It already knew about those. We didn't have to add those. We added 10.0.1.0, which is here, 10.0.1.0, and 10.0.2.0, which is here, and they're through the next hop of 10.0.0.1. And then the local routes are shown here with the /32. Those are the interfaces. Okay, so we got these two networks added. Now we need to work over to the left. So it's directly connected to this network. We can skip it. We need to set a static route for 10.1.1.0. And so let's set an IP route for 10.1.1.0, subnet 255.255.0. And the next hop here is going to be 10.1.0.1, which is the interface on R3. That's done. And then let's do the next network inline, which is going to be, oh, did I make a mistake? I did the 10.1.1.10 with the next interface of 10.1.0.1. Yeah, that's correct. Okay, so the next one we have to do is going to be 10.1.2.0. So let's just change that. That one's added. And then now let's add the 203. So IP route, and the network we're setting up is, or setting a static route for is 203.0.1.1.0.113.0. Subnet Mask is also a /24. And the next hop will be the same for router 2, which is over here. So 10.1.0.1. And then let's do show IP route. And just so you know, the do command, typically, I'm going to use Control U to just erase that line. Typically, you're going to issue show commands in the privilege exec mode, or also called the enable mode. But if you're in, say, if you're in a different mode, you can use the do command to override, to tell it, you know, it reminds me of like when I've played with Linux, the sudo command. It's like a superpower. It does it for you anyway, even though it's not typically a command there, that mode. So we're going to do show IP route. And for router 2, now we've added, it was aware of 10.1.0.0. We added 10.1.1.0, which is here. 10.1.2.0, which is here, 203.0.1.1.3.0, and let's add the last one, which is IP route. The command in the network is 10.1.3.0 with the subnet mask, and the next hop is going to be the same of 10.1.0.1. Okay, up arrow a couple times, and now we should have 10.1.3.0 there as well. So that is router 2. Now we move to router 3. Again, we need to make it aware of the networks over here. We'll go to the right. So pull it up. Privilege exec mode, global configuration mode with configure T terminal. So let's start with IP route for 10.0.0.0 and subnet. And the next hop for R3 to that network is on R2, which is the 10.1.0.2 interface over there. So we'll do that. And then we'll add the 10.0, next one, 10.0.10. So we'll just change this. Everything else will stay the same because it's the same next hop. Let's do for 10.0.2.0. That's there. So let's take a look at show our routing table, IP route, and we should see everything from this interface over. So 10.1.0.0 is right here, 10.1.0.0, and the next one is 10.0.0.0, which is here. That's my phone if you heard that. Then 10.0.1.0, 10.0.1.0, which is here, and then 10.0.2.0, which is here. Okay, so we have 10.1.0.0, 10.0.0.0, 10.0.1.0, and 10.0.2.0. We got all of these configured. Let's actually, we need to add that one too. We need to add the 10.0.3.0. So 10.0.3.0, and now we should have everything. There we go, 10.0.3.0. All right, so everything to the right should be configured. Now let's look over to the networks to the left. It's directly connected to the 10.1.1.0 network, so we don't need to do a static route for that, but we do for these three. So IP route of 10.1.2.0, subnet mask of 255.255.0 because it's /24. The next hop in this direction is going to be 10.1.1.1. So 10.1.1.1. Okay, that should take care of the 10.1.2.0 network. Let's do the 10.1.3.0 network next. So I only have to fix one little thing, which is the 3 there. Hit enter. And then the last one is going to be the 203. So we'll have to change that. And we will make that network address of 203.0.113.0. Okay, and the next hop again would be the same. Okay, so do show IP route. We have R3 is aware of 10.1.0.0. Okay, and everything going to the right. Now over to the left, 10.1.1.0. So that's right here. It's directly connected. Then we're going to go to 10.1.2.0, which is here. We got it. 10.1.3.0, we have it here, and 203.0.113.0, which is here. So that is R3. We need to do the same for R4 now. Let's pull it up. And we are in global configuration mode. So R4, let's again start by working to the right. It's already going to be aware of this network because it's directly connected. So let's start with the 10.1.0.0 network. And we're going to set the static route with the command IP route, and then the network address 10.1.0.0, Subnet Mask. And the next hop from R4 towards this network is going to be 10.1.1.2. So 10.1.1.2. Okay, so we've got the 10.1.0.0. Now let's add the 10.0.0.0. And we can do that with a quick little switch there. And then 10.0.1.0. And we can add it by doing that. And 10.0.2.0. So up arrow, bring it over, 2.0. Okay, so we should have all the networks. Oh, 10.0.3.0. Don't forget that one. All right, and that should be everything. 10.1.1, 10.1.0.0, 10.0.0.0, 10.0.1.0, 10.0.2.0, 10.0.3.0. we've got everything to the right. Now let's work with everything left, which are these two networks. Our 4 is directly connected to this network, so we don't need to add a static route. We won't need to add a static route here either, because once these interfaces here and here are up, looks like that one is up. Once we bring this interface up, it's automatically going to add this network to the routing table. So let's do show IP route to confirm, and we will quickly run through. So R4 is aware of 10.0.0.0, 10.0.1.0, 10.0.2.0, 10.0.3.0. Okay, and then it's also aware of 10.1.0.0, 10.1.1.0, 10.1.1.2.0, which is this one, and we are missing the 10.1.3.0. Okay, so we need to add 10.1.3.0. So IP route, actually we don't. It's going to be directly connected to that one, so that's not necessary to add a static route. Once these interfaces are up, it'll become aware of it, and it'll add it automatically. All right, and I do believe it said don't do anything with R5, so we're going to leave that. So we configured IP addresses on routers 2, 3, and 4. Got that done. We verified that PC could ping. We configured static routes on routers 1 through 4. Verified connectivity between PC 1, 2, and 3. So let's start with PC 1, and let's do a ping, and let's ping PC 2 again, even though nothing should have changed that would affect the previous connection. So yeah, it's up. Okay, and then we're going to ping PC 3, 10.1.2.0, 2.0, 10.1.2.0. Okay, and let's see, it should send out an ARP request, so the first one will fail, probably the first ping. So it timed out, but hopefully if everything's set up right, we will get an echo response. Nope, something's wrong. Unless it was just doing another ARP. Not sure. We're going to find out. So, we did receive one. So let's try it again. I think it's okay. There we go. We're good. So pinging from PC 1 to PC 3, it's working. So we did that. Okay, I think we finished the static routes it wanted us to do. Oh, let's verify the path the traffic takes from PC 1 to PC 3. So we're going to do a Tracerout. So let's pull up the command prompt, and we're going to do the Tracerout command. It's just trace RT in Windows. Tell it the IP of where you're going to. 10.1.2.10 is PC 3. And from PC 1, the next hop sequence what we should see is it should go to 10.0.1.1, then to 10.0.0.0.2, then to 10.1.0.1, then to 10.1.1.1, and then finally to the PC. So let's see what happens. All right, everything looks good. So we made it from PC 1 to 10.0.0.11, which is here, 10.0.0.2, which is here, 10.1.0.1, which is here, and 10.1.1.1, which is here, to 10.1.2.10, which is the PC. So we're good. All right, so it worked like we thought it would. That's good. All right, now we want to set up summary route. So a summary route is with the static route. Say we were working on R1. We statically set up each of these routes that it wasn't directly connected to, and you have to enter commands in for each one. Now a summary route allows you to issue one command to make this router aware of the path to take to get to at least all of these networks. We can do one command for this one, this one, this one, and this one, and I'll show you how that works. So let's go to R1. And it's said to remove all the static routes. Okay, well, let's do that first. That's easy enough. So enable conf t, and let's do show IP route. Okay, and here are, I'm going to hit the space bar. Here are the static routes that we configured. 1, 2, 3, 4. Looks like 5 of them. So 1, 2, 3, 4, 5. Yes. And to get rid of those routes, typically when you add a static route, you would type in IP route and then etc. the name of the network and the subnet, etc. We want to negate that command, so we're going to enter the no command first, which is basically going to remove them. So we'll do a Control E to get to the end. So we're going to do a no IP route for 10.1.0.0, 1.0.0 with a 255, 255, 255.0 and a subnet mask of 10.0.0.2.0.2. So that'll undo that command. Okay, and so if we do show IP route, you can see here we did the no IP route for 10.1.0.0. It was there. Let's see if it's gone. 10.1.0.0. It's gone. Okay. Let's go ahead. I want to see what happens if I do a no IP route and leave off and only include the network IP. I don't think it'll work. Yeah, it's an incomplete command. So we took off 10.1.0.0 and now let's take off 10.1.1.0. So 10.1.1.0, 255, 255, 255.0. The next hop was 10.0.0.2. And let's do a no IP route then for 10.1.2.0. 10.1.2.0. Up arrow. We're going to get rid of the 10.1.3.0 next. Get rid of the static route for that. And then we're going to do the final one, I think, which is 203.0.113.0. And let's do a show IP route command, and all our static routes are gone. So we completed the first portion, remove all the static routes on R1. So it says verify that PC1 loses connectivity to PC3. Okay. Now you would look at the topology, the diagram here, and you'd think, well, everything's green. It looks connected, but the problem is R1 doesn't know about anything beyond this network going this way towards PC3. So it has no idea how to reach there. So let's ping PC3 to verify it as it asked. So ping 10.1.2.10 and we're getting a destination host that's unreachable. So yeah, it's not going to work. And we did verify that it loses connectivity. So now it says restore connectivity to all subnets with a single command on R1. And this gets back to the summary routes that I was talking about a little bit. And I'm going to show you that command where instead of manually configuring static routes for each of these networks, at least for these 1, 2, 3, 4, we'll be able to do one command. So let's pull up R1 and I'll show you that command. Okay, so we're going to do an IP route, and the difference is if you look at the common factor on each of these, you have 10.0.0.0/24. They're all /24s. We don't need to worry about 10.0.0 because it's connected directly to R1. But we have 10.1.0, 10.1.1.1, 10.1.2, 10.1.3. The common factor are the first two octets, 10.1, 10.1, 10.1, and 10.1. So we can tell this router the summary route of 10.1, everything that is for 10.1 or below or above, however you put it, is going to go through this next hop. So we're going to do, and the way you do that is with the subnet mask. So right now this is /24, so 10.1.1, those three octets are in the network, and the last is the host, the 0, same here. But if we change it to a 16, we can say, okay, so just look at the 10.1, the first two octets, that's the only part of the network we're worried about, and let's do that. So we're going to do the 10.1.0.0, and here's the difference. Here's the subnet change. we're going to give it a /16 instead of a /24. So 255.255.0.0, and the next hop is going to be 10.0.0.2, 10.0.0.2. Okay, and now when we do show IP route command, we're going to see something cool, hopefully. Yes, so everything in the 10.1 network, 10.10, 10.11, 10.12, 10.13, because we designated as a /16, is now going to go through 10.0.0.2, the next hop. We did all of that with one command, which was this one right here. IP route, then the network, then the subnet mask, and then the next hop. So let's take a look at what the issues were. Okay, restore. Okay, so we did restore connectivity to all subnets except this one with a single command in R1, because you couldn't configure this with a single command because these are the 10.1 networks. Okay, so it says verify the routing table in R1 does not contain any /24 routes to remote subnets. Okay, so we can do that really quickly, and we'll do show IP route, and there should be no /24. The only ones that should show are the directly connected here, directly connected, and directly connected. So we verified the routing table does not contain any /24 routes to remote subnets. All right, so now let's ensure that connectivity is restored between PC1 and PC3. Well, it should be, because now we made R1 aware of all these networks going all that way. So let's pull it back, pull up PC1. Let's do the command prompt, and let's ping 10. What is it? 10.1.2.10 is PC3, and it's good. We got a good successful ping. Ensure connectivity is restored. Done. So now we're going to go to the longest prefix match. We're going to cover this topic. So configure IP addresses on R5 according to the lab topology diagram. So let's configure IP addresses on 5. So we need to go to privilege exec mode, conf p, and then we're going to configure IP addresses according to lab topology. So we're going to give an IP, nope, we got to go in the right interface. We got to go to interface, fast Ethernet 00, and we're going to give it the IP address of 10.1.3.2, 10.1.3.2, with a subnet mask of 255.255.255.0, because it's a /24. All right, and then we're going to do the no shut command for no shutdown, and you can see it when active there. And then we're going to do, we have to work on interface fast Ethernet 01. We're going to give it an IP address of 10.0.3.0, because it's part of this network. 10.0.3.2 though will be its IP address, and 255.255.255.0, and no shut, and do show IP interface brief. Make sure we did everything correctly, and we should see it. Yes. So fast Ethernet 00 has the 10.132 IP, and fast Ethernet 01 has the 10.032, and they are both up. So we've done that. So we did number 19. Now let's go to 20. Do not add any additional routes. Okay, so does PC1 have reachability to fast Ethernet 00 on R5? If so, which path will the traffic take? Yeah, it should, because R1 is aware of all of these networks. It's even aware of this one. So let's see what path it takes. If so, which path will it take? So let's ping this interface from PC1, and actually we'll traceroute instead of ping. Well, we can ping first just to make sure it's working, I guess. So 10.1.3.2 2 is the interface. And if it's working, we should get maybe a couple of ARP timeouts, but then we should see it working. So give it a second, request timeout. That's probably ARP, I guess ARP again. But let's see what happens now. Hopefully we've got it. And one more try. See what happens. Okay, so no. Let me ping one more time just to make sure. And yeah, it's not working. So why does it not? So I may have made a mistake somewhere. So these interfaces were up and PC1 is trying to ping here. So let's do the traceroute command. That will tell us. I probably should have just done that. Would have been easier to do that to begin with. So traceroute to 10.1.3.2. All right, let's see what's happening. So we started PC1. It made it to 10.0.1.1, which is, move this over, 10.0.1.1, which is here. It made it to 10.0.0.2, which is here. It made it to 10.1.1.1, which is here. Then it made it to 10.1.1.1, which is here. And then it stopped. The request timed out. I'm not sure why that's not working. So does it tell us? If so, which path will the traffic take? Okay, so this is where the answer key comes in because I made a mistake somewhere, I think. So we're on number 20. Let's go to 20 down here on the answer key. I mean, I could just walk through and look at each one, but that would take forever. And we are doing a video, so okay, do not add any additional routes. Does PC1 have reachability? Okay, so summary route on R1 will provide a route to R5 over the path of R1, 2, 3, 4, 5. Oh, okay, so, but router 5 does not have a route back to PC1. I get it. Okay, well, this is, so what's happening is the packets are getting here. I think here, let's look at it. Let's pull up PC1 and let's open the command prompt and then let's pull up. It's still, I'm not sure how you break out of that. I forget how to break out of that. Well, we'll give it a second to do that. I don't want to wait that long though. So what happens if I close it and open it back up? I forget. It's probably still running. It is. So I'll show you in a second, but I think what we have to do, well, let's see what the next issue is. Ensure reachability over the shortest path from R5 to all directly connected networks on R1. Okay, well, we can do that. We'll set up a path for that. Let me see. I'm going to try, let me go back here to the command prompt. And I wish I knew how to break out of that. Would have been nice for me to learn that before I did this on the video, probably. All right, well, I'm going to skip what I was going to show you, so we'll just let that run because it looks like it's going to go 30 hops. I don't know how long it's going to try that. Can't think of... Anyway, we'll let that run. So ensure reachability over the shortest path possible from R5 to all directly connected networks on R1. Oh, I know what I was going to show you. I think I can still show you. Let's do, pull this back. So we've got R5 pulled up. And I want to, I think we should be a debug mode. Yeah, so debug, and then let's do debug IP, and then IP, ICMP. Let's try that. Okay, so debugging mode just is, see, look, okay. Now over here, this is cool. So we've got, I'm going to do another one too. I'm going to pull up, I'm going to ping from here. I want to show you this. So PC2, if I try to ping 10.1.3.2, which is over here, 10.1.3.2, okay, it's pinging. So let's go back over to R5 and we have the debug mode on. And, oops, so we have 10.0.2.10. I should see it, but I don't. All I'm seeing is the ICMP echo request being sent back to, oh, there it is. Okay, yeah, cool. Look, 10.0.2.10 is PC2. I did a ping. Look, right here is where it is. So what's happening is, and then these other echo replies are going back to PC3 up here. This is actually kind of cool because you can see, so 10.0.2.10, which is right here, it pinged it. And the pings, actually, sorry, I keep doing that. The pings actually made it from PC2 to 5 because we're looking in debug mode at 5 and we could see that they came from PC2. So why did PC2, if it's able to get a packet all the way to here, why did PC2 show a request timeout? And the reason for that is a successful ping is not one way. It's got to get there and get back. So a successful ping is making it to the destination and then being able to get back. And in this case, we saw that it didn't happen, so it wasn't successful, it timed out. And the reason for that is R5 doesn't know about these other networks yet, because remember, we didn't configure it. So we want to do that now. Ensure reachability over the shortest path possible from R5 to all directly connected networks on R1. So it's telling us add these networks from R5 over here. So this one, and this one that are directly connected to R1. These three. R5 will know about this one, but we need to add these three. So we need to add 10.0.0.0, 10.0.1.0, 10.0.2.0. And we can do that. Let's pull up R5 and let's see here. I'm not sure how. You know what I'm going to do? I'm just going to cheat. I don't know how to turn this off. In Packet Tracer, I don't know how to stop it. There it goes. Okay, Control Z. There's the answer. But I don't think that worked over at PC3. Let's see. Yeah, finally PC1. Was it PC1 we did the Tracerout? Yeah, and it finally just pooped out. So we're good. All right. So from R5, we need to make it aware of. It knows about this one, so we need to make it aware of these three on the other side of R1. So let's go into global configuration mode, and let's set an IP route. And these are 10.0.2.0, 10.0.1.0, 10.0.0.0. So let's just set a summary route for 10.0 with a subnet of 255.255, a /16. Let's see if that works. 10.0.0 .0.0, and I'm going to give it a subnet mask of 255.255.0.0 because it's going to be a /16 because we're only worried about these first two octets, the 10.0 octet. And then the next hop for R5 is going to be this way on the 10.0.3 network at fast Ethernet 1, and that's a 1. So we have the network that we want, the correct subnet. This should be a good summary route. And do show IP route. All right, there we go. 10.0.0.0. Anything 10.0.0 and above or below, however you want to look at it, should be there. So it's said to ensure reachability over the shortest path to all directly connected networks in R1. Did that with a single command. Okay, so you did want a summary route. Verify the path traffic takes from PC1, which is here, to fast Ethernet 0.0 interface on, which is over here, router 5. Okay, well, to verify the path, what we're going to do is Tracerout. And I hope it works, because I don't know how to turn that off. So it's Tracerout, TraceRT in the command prompt for the PC. And we're going to 10.1.3.2. See what happens. Ah, good deal. So we can see, well, at least it's partially there. Sorry, I keep doing that. And I did it again. Let me open this up a little bit. Okay, so from PC1, it went to 10.0.1.1 as the first hop. This network 10.0.1.1. Then it went to 10.0.0.2. Then it went to 10.1.0.1, 10.1.1.1, and then it made it to 10.1.3.2, which is this interface. So it did make it, but that I wouldn't consider the most direct route. I would have thought this way. Ensure the traffic between. Okay, so it says ensure the traffic between PC1 and fast Ethernet 0.0 and R5 takes the most direct path in both directions. Okay, well, let's do this then. Well, in one direction it didn't, so I forget how to get out of debug mode. There we go. Okay, so we need to turn off the debug mode, by the way, on R5. Just clear this. Oh, I got to get over here. I got to get into the, so there it is. Debug IP ICMP, and just issue no in front of it. That'll turn it off. Okay, ICMP packet debugging is off. Okay, that's what we want. Now let's look at the route. Let's do a trace route from here to here. So I think it, is it here or is it global configure? Yeah, so trace route to 10.0.1.10. See what happens. Okay, it got there and back. So it went to 10.0.3.1, which is 10.0.3.0, 10.0.3.1, which is here, and then boom, it made it, no problem. Okay, so it says ensure traffic between PC1 fast Ethernet 0.0 on interface and R5 takes the most direct path in both directions. Well, it didn't. It didn't take the most direct path coming from PC1, but it did going back. So let's look at the answer key right quick. Let's see. All right. So yeah, we did that. We did a summary route. Where was I again? On 24. Oh no, 25. Sorry, I was looking at the wrong thing. All right, verify the traffic between PC1 and fast Ethernet 0.0 on R5 takes most direct back in both directions. So in the answer key, it was ping. He did the trace route. R5. I don't know. I think that it might have something to do, traffic to 10.1.3.0, what are they talking about there? Here. Will now match two routes in the routing table. Okay. And a 16 and a 20. Oh, okay. So let's look at that right quick. Actually, we'll just look at their notes because I think I know what's going on. I think the routers like to take the most specific path. In other words, See how this is a /24? I'm not sure. I think it has something to do with that, but I'm going to skip it because the video is getting long. Okay, verify the traffic between PC1. Okay, default route and load balancing. Configure an IP address on the internet, fast Ethernet 1.1 on R4, which is here, according to the lab topology. So we need to add the IP address for this interface. So let's do that right quick. And enter, and enable, and Comp-T. And we're going to go to interface, fast Ethernet 1.1, and we're going to give it the IP address of, it should be 203.0.113.1. Now, forget the subnet again. 255.255.255.0. Thank you, Cisco IOS, for reminding me. Do show IP interface brief. Look. Okay, 1.1 is up. Okay. Oh, administratively down. Duh. No shut. That'll take care of that. Do show interface brief, IP interface brief, and it's up. Okay, good. That's working. By the way, this little yellow thing right here, that I think that that's a spanning tree. So it's spanning trees is still doing its stuff. Look, if you speed up in time, it goes green. So spanning tree's done. Thinking. All right, we configured the IP address on R4. Now it says ensure that all PCs have a route out to the internet through the internet service provider, which is right here. This is the internet service provider with 203.0.113.0, no, 1.132 is its IP, but it's there. And note that the lab does not actually have internet connectivity. Ensure that all PCs have a route out. Okay, to do that, I think we need to set a default. Hold on. So ping 203.0.113.0, no, .2. Actually, yeah, that'll work. Let's see what it does. Unreachable, unreachable, unreachable. Okay, so it doesn't know. Oh, yeah. Well, that's right, because we didn't configure this network. Ensure that all PCs have a route out to the internet through the internet server. Okay, here, I think we can do this. So pull up R1 and enable Comp-T, and we're going to go into IP route. We need to set up the gateway of last resort. Which basically is saying, hey, if you can't find it through the stuff, the other matching lists in the routing table, take this route. Let me see if I remember how to do that. IP route, and we're going to do 0.0.0.0, 0.0.0.0, no, get rid of that. 0.0.0.0, and then for R1, we're going to do a next hop of 10.0, 10.0.3.2, because that's the interface over here. So this is just saying, hey, this by default, if you can't find any other way, try this way, if I remember correctly. All right, so we're at R1. Let's go back to, let's do show IP route. Let's look at that right quick. All right, so, yeah. Okay, see, yeah, it was. The gateway of last resort is 10.0.3.2 to network 000. So this is, it's saying, hey, if you can't find whatever you're looking for, go over here and see if it'll happen. So let's see what happens. I think I need to set it up here too, at least one more. So Comp-T, and then let's do an IP route. And we're going to set it as 0.0.0.0, 0.0.0.0, and the next hop will be here. So 10.1.3.1, and let's go back to PC1, and let's try to ping the ISP. Ping 203.0.113.0. Boom, it worked. Okay, and the reason why that worked, you notice we didn't set up, I only told it this route. Basically, I told R1, hey, if you can't find it, go here. And R5, I told it, hey, if you can't find it any other way, try this way. Well, R4 knows about this network, so it worked. So that's a cool command, setting up the gateway of last resort. And it basically tells the routers, if you don't know any other way to send this, just send it this way, and hopefully it'll get there. And it did, and it worked, so that was kind of cool. Now, you would need to do that too over in these routers as well, but I don't think it really is asking us to do that. Ensure all PCs have a route out to the internet through the internet service provider connection on R4. Okay, so yeah, so if we were to do so, this PC will make it. So let's try PC2, it should work. Command prompt, ping. We want to ping 203.0.103.203.0.113.2. That's what we're trying to ping. From here to here. And I set the gateway of last resort on R1 and R5, so I think it should work. I think it's sending an ARP request right now. Could be wrong. I may have missed something. Let's see. 203.0.113.0. Let's trace route it to 203.0.113.2. So it went to 10.0.21, 10.0.21, which is here. And then it went to 10.0.32, which is here. And then it went to 10.111, which is here. I don't know why it took that direction. In other words, it tried to go back this way. 10.1.1. Oh, you know what? Maybe I do have to. Hold on. Let's try to do that. Exit IP route. We'll do the same thing here. 0.0.0. 0.0.0.0. But I don't know why I would have to on this one, but we're going to do it anyway. 203.0.113.2. I'm not sure this is it. This doesn't seem right to me. Let's see, it's still timing out. Anyway, see if the answer key gives a clue. So we're down at like 27. Ensure that all PCs have a route out to the internet. Okay, see, yeah. I should have set up the gateway of last resort on all the routers. Yeah, all routers should have a default route to the next hop IP and the path to the internet. So that's what I missed. Yeah. Okay, so it worked from here, but I needed to finish configuring. But this video is getting long, so I'm going to cut it off. You know what I missed. I needed to set the gateway of last resort on 2 and 3 as well. I think I did it on 4. Let's go to the last thing. Traffic from PC1 and PC2 going to the internet should be load balanced over R2 and R5. Okay, so I need to actually, I got to do it right quick, even though the video is getting long. IP route 0.0.0.0, nope, 0.0.0.0, and for R2 it's going to be 10.1.0.1. 10, next hop will be 0.1. Okay, that should be there. That should be gateway of last resort. Let's go to R3 and do the same thing. T and IP route 0.0.0.0, 0.0.0.0. R3 is going to be, next hop will be 10.1.1. What is it? 1. Okay. And I think I did it on R4, didn't I? Let's see. And I'm not sure I should have done it that way. to tell you the truth. Do show IP routes. Let's see what happens. What is it showing? All right, it's saying its gateway of last resort is 203.0.1132. I mean, let's see what happens over at. Sure, all PCs have a route out to the internet. Okay. And traffic from PC1 to PC2 should be load balance going over. In other words, it should be taking both routes. I'm not super clear on load balancing yet. Other than it's just kind of what it sounds. Instead of just shoving all the traffic in one direction every time, the router will make decisions on where to go. So let me try to ping the ISP 203.0.113.0, and it's working. Okay, that's good. And then I want to trace route the same thing, 203.0.113.2. Oh, I messed up actually. That should have been a ping 1132. Hold on. Ping 203.0.113.2, which is the ISP. That's what I actually wanted to ping. And I'm not sure if that's working. Timed out. That could be an ARP request. We'll see in just a second. If it keeps timing out, we'll know that I made a mistake. And that's okay, because that's what these labs are for. Now, they're not the video. It's not making for a great video for me to go back and check every single interface, every single router, everything. I'm not going to do that. Just know that I made an error somewhere. I'll have to walk back through and figure out where I made the error. And that's the fun of the labs. I mean, to me, it's like, okay, I broke something. Let's go fix it now. But anyway, that's it. That's the video. I'm going to end on a negative note, I guess. To me, it's not negative. It seems positive to me because I get to keep playing with this and figure out what I did wrong. But the video, it's time to end it. This is a lab on static and summary routes from Flackbox, Flackbox.com. Make sure you see this guy, Neil Anderson. He's a very good teacher. His courses are one of the courses I'm taking to study for CCNA. And I take his, I do CBT Nuggets and David Bomble's Udemy course. I like to have a variety of teachers because I'll pick up bits from, you know, if I'm not understanding something from Neil, I'll go back to CBT Nuggets like Jeremy Chara or back over to David Bomble. And then, you know, out of the three, somebody's going to teach me in a way that it'll click with me and it'll sink in. So I hope you've enjoyed this. I'll do some more if it seems like y'all enjoy watching this. And I hope everyone has an opportunity to play with some labs like this. It's lots of fun. Thank you.